Welcome to the talk. It's going to be automate your containerized applications with Podman and Ansible. So first up, just an introduction. So my name is Ricardo Carrillo Cruz, or you can just call me Ricky. I'm a principal software engineer at Red Hat. I've been there for 6 years and a half now. Pretty happy. I've been doing lots of things. I'm a member of the productization team of Ansible. We're basically responsible for building and delivering the various offerings that we have, for Ansible. We have Ansible Core, but we have other offerings in cloud, many different components. So that's what my team does. Previously to that, so I was working back in the day at HP. I was heavily involved with OpenStack in the project. Then I joined Red Hat with Ansible. I was doing there quite a few things, mostly network automation, cloud, and CI/CD. Then I eventually moved to the upper shift engineering. I was part of the networking team. I was there for a couple of years. And my previous role to this one, I was doing some telco stuff at the CTO office. On a personal note, I'm from Marbella, which is close by from here. I also studied here in Malaga, which is it's nice to be here, to be back around home. So first off, I'm going to give a brief introduction of what Podman is. Then I will give another brief introduction about Ansible because I don't want to take assumptions about what people know about Ansible. Then I'm going to talk how you can integrate Podman and Ansible to automate it. And then, depending on time, we can do a demo, maybe two. It depends. So what is Podman? So Podman is a container engine to build, run, and manage containerized apps. So you can pull images from Docker Hub, from Quay, from whatever, registry. You can build. You have a Docker file, container file. You can build images with it. And then you can run containers with it. It's open source, obviously. It's an open source conference, and we are Red Hat. We do everything open source. It supports and follows the standards for containers, specifically the Open Containers Initiative. So it supports container images that follow the OCI standard and also the OCI runtimes like C1, runc. They support all that. So as you can see, it's just similar to Docker, but it's different. It has some differences, which I'll cover in the next slides. So what makes Podman different? So first off, one of the key things that why Podman was developed is because Red Hat wanted to support rootless containers from the ground up. In the beginning, Docker didn't allow that. So with Podman, you can just do it. If you're not root, you're a regular user, you can actually run a container and run it, which makes it more secure because if there's a vulnerability within your application, then if there's a privilege escalation, it's running at the host level as a non-root, so that makes it more secure. It's daemonless, doesn't run any kind of daemon. Unlike Docker, which you need to have the Docker daemon listening in order for the CLI to interact with it. With Podman, you don't have anything. You just have a binary, which you use it for building and running the containers, that's it. So how it makes it, so it's because it uses the fork and exec model, which is, just how regular, Unix and Linux works. So when you run Podman, it will spawn the container runtime, and then the container runtime will spawn the container, and that's it. You don't have a daemon managing all that. Is Docker CLI compatible? It aims to have the same options as the Docker CLI. As a matter of fact, you can have an alias, create an alias in your bash shell or whatever, and basically use Podman even if you were using Docker. Even if it's daemonless, you also have the option to have a remote access to it via an option or REST API. It's not needed. Let's say that you have a laptop and you want to create containers in a target machine. So you could SSH to it and do it, but you can also have like a REST API, which you can just hit from your applications. The cool thing about this is that it's not Podman listening as a daemon, because as we said, it's daemonless. So it leverages systemd socket activation. So systemd will be listening to the port for invocations of Podman. And once it gets a connection, then it will proxy those requests to Podman. So it's, not, it's similar to the init daemon from back in the day. So it's a similar feature. So it also integrates with systemd. Maybe you have like traditional applications which you are managing with systemd, which is the de facto init service manager for starting services, stopping services, managing the dependencies between services. It's very feature rich, but with Docker, it's very difficult, if not impossible, to have like systemd managing multiple services within a container. So with Podman, you can just do it. It will prepare the containers to allow systemd to manage those services, and it won't mess with it. It would just, allow systemd to take care of all things. It also has a really cool feature, which is the automatic update of containers on new image versions. So, meaning you can have your containers, and you can label them and say, hey, I want this Podman container to have automatic updates. Then, if you run a Podman auto update, Podman will go through all the containers in the system and check for that label. And then what it will do, it will either go to an external registry or the local registry, compare the versions if there's a new version in the registry, and then it would just, update the container. So you can do that manually by running the Podman auto update, but you can also have like a systemd service that on a timer will perform that automatic update check. This is actually a good one. So it supports pods of containers. It's actually what gives Podman its name. So Podman stands for pod manager. So what's a pod? So maybe you've used Kubernetes, maybe not. A pod is just a group of containers that they are very intertwined. They are supposed to be working in conjunction, and they share the same network and the same volume to communicate between them. So this is actually a cool thing, because you can have that pod concept from Kubernetes just running into your containers. You can have like maybe 2 or 3 containers that you want to have to run them together, and you don't want them to be decoupled. You can just shove them into a pod. And talking about Kubernetes, this is actually a very neat feature. So you can generate Podman pods from Kubernetes manifest. So imagine that you have a deployment manifest from Kubernetes for an application, and for whatever reason you don't want to run it with Kubernetes, you just run it as a regular container. So with Podman, you can just, with one command, it will take that Kubernetes manifest and create a Podman container for you, which is actually very neat. And the other way around, you can also, if you have your Podman containers, and let's say that you want to migrate to Kubernetes, you can generate Kubernetes manifest of your Podman containers. And the cool thing about this is that it will even generate from your Podman volumes, Kubernetes volumes, Podman secrets to Kubernetes secrets. So there's like a kind of a one-to-one relationship there, which is actually quite nice. Should you use Podman over Docker? It just depends. If you are happy with Docker, you are heavily invested in Docker, maybe not. However, if you are interested in all the features that I put you, which kind of differentiates from Docker, it's good that maybe it's worth checking it out, and also because it's heavily developed and maintained by Red Hat, because it's a strategic initiative, and also because it also integrates very nicely with Ansible, as we will see in a moment. So now, what is Ansible? Ansible is an IT automation tool. It basically allows you to automate IT processes, configuring a server, installing a server, a firewall, all that kinds of stuff. It's open source, obviously. Again, we're Red Hat. We do everything open source. You can just, modify. You can contribute. It has a really vibrant community. I encourage you to go and join if you're interested, because we're always looking for contributors, and they're very welcoming. It's very easy to learn and use. It's just YAML. Often is said that Ansible playbooks, they're like human readable like documentation, because you don't really need documentation for a lot of things, because the playbooks themselves, they are so easy to read and learn that they're you don't even need to document at times. It's agentless, so you don't have like in some of the systems like Salt or Puppet, where you may have like a central server and your target nodes, you have like an agent. With Ansible, you just have Ansible. You connect from the place you are running Ansible, from your target machine, you connect to those servers, and then you configure them. You don't need to install anything on your target servers. It's highly extensible with plugins. Pretty much everything within Ansible is plugin based, so you can change behavior, you can extend it, which is great. So what you can use Ansible for? Configuration management, configuring servers, installing packages, creating users, setting firewalls, that kind of thing. Infrastructure provisioning, creating resources in AWS, Azure, GCP, Vultr, OpenStack. We have like modules for pretty much every cloud out there. Also for bare metal provisioning as well. Application deployment, you can use it for deploy your applications, as we will see in the demo. And orchestration, this is my favorite, because Ansible is so simple to use, and it integrates with so many different things. We aim to integrate with everyone, rather than having an opinionated way of doing things. We just try to play with every single system that you may find in your IT environment. So it's great. It's a great tool to orchestrate the different tools that you may have in your infrastructure. It's great use for hybrid cloud, because you can do all sorts of things in the major hyperscalers, but you can also use it in your VMware, in your OpenStack, whatever you have in your bare metal servers, you can just use it. For networking, this is actually a really big use case. Ansible has lots and lots and lots of modules for managing networking devices, the Ciscos, the Junipers, the Aristas, and we even have like a content team just for networking to create and maintain that content. Security automation, configuring firewalls, intrusion detection systems, source systems, that kind of thing. And now we're also, getting a lot into Edge, IoT, that kind of use case, because it's so lean, Ansible. You don't need to install really anything into a server to actually manage it. It's agentless, so it bears for that use case really well. So concepts. So in Ansible, you have a control machine, which is where you run Ansible. And then from that machine, you connect to your targets. The target nodes can be servers, networking devices. They can be firewalls. They can be cloud endpoints, anything that you want to manage, basically. Then you have the inventory, which is a file where you put the information on how to connect to those target nodes, the IPs, the users, the private keys that you need to use to connect to that, and then the playbook. And the playbook is how you define what you want to automate. So you define your target nodes that you want to automate, and then the tasks, which are the things that you want to do to automate. We're seeing in an example. So this is an inventory. As you can see, it's an ini format file. It's really simple. You can have groups of machines. It can be much more complicated than this, but this is like maybe the simplest version. So here we have a databases group, which has that IP, and we have the web service group, which has 2 machines. So then later on with Ansible, we will be able to target the databases, and it will run the task against that IP, And if we run a playbook against web service, it will run the task against those two machines. So this is a playbook example. As you can see at the top, you can see the host directive. This is where you are specifying your targets. So this playbook is aiming to automate things against the web servers group from the inventory. We're telling that, hey, you should connect with a root user to those machines. And the task is actually what you want to automate. So in this example, you can pretty much, read, it's a straightforward. It's going to install with Yum the HTTP package, the latest version. And then it's going to templatize a Jinja file, because Ansible supports Jinja templating, from the local machine HTTPD J2 to the target machines at etsy.httpd.com. So then in Ansible, we have modules. So what are modules? Modules, they're just like the business logic for the task. So if we go back here, you may be wondering, okay, so how that Ansible built-in Yum does what it's supposed to do, because there's a module for that task. So there's a Yum module, there's a template module for everything that you do, basically the business logic for Ansible for doing things, performing change against your target servers. That's what modules are for. They're mostly written in Python because they accept JSON and they return JSON, but you can use any language. I mean, I've seen modules written in Bash, even Golang, but from a community perspective, all the tooling, CI/CD, and the linters and everything is pretty much in Python. They're easy to develop and ship. You can very easily imagine that you have a need for a particular task that you don't really find a module for it. You could very easily develop a module in Python and create a library folder alongside your playbooks. There you put your module, and it will be visible to your playbook. So you don't even need to push a patch and expect to be shipped somewhere. You can have locally in your playbooks modules that you can just use. As part of the modules, so there are built-in modules which are part of Ansible core. The bare bones modules for doing the most basic things. Then there are the Ansible content team modules. So my organization, there's a specific content team for networking and cloud where they develop, maintain, and support modules for things like AWS, for managing Cisco, Juniper, that kind of thing. Then we have a vast ecosystem of partners where they develop modules and then they publish them. The Dells, vendors, all kinds of things. Anything that we cannot really reach because Ansible is so big and we cannot possibly support everything, there are partner modules. And then, because we have such a big community, there are modules that they are developed and maintained by the community themselves. Then, besides that, the modules, we have what we call roles. If you remember when we saw the playbook example, you were inevitably tying the task to a particular host or target nodes. Now, it would be good for reusing if you somehow you want to automate, for example, imagine that you want to automate installing an Apache package and configuring Apache. So rather than having a playbook for each one of the specific variations of configurations of Apache, which may differ in your environment, you may want to have a generic Apache role to configure it, which is generic, and you just can reuse it in any playbook, and it's not tied to a particular target. So that's what roles will allow you to do. They encapsulate content such as tasks, Jinja templates, variables that to automate a particular service or process. For reusing the thing, once you have the role, you just use as a task include import role, and it will just include or import that role against the target service. This is the structure overall. It's very straightforward. So it contains, so here's a role named common. It has a task folder which contains the task. Then it may optionally contain Jinja templates within the templates folder. It may also contain optionally files, which are not meant to template because it's hard-coded and they're going to be the same all the time. You can also have specific role variables and even defaults. There are some other things that you can ship within a role, even plugins and other things, but these are like the basic things. Then we have plugins, which extend or modify core Ansible capabilities. There are a large variety of plugins, connection plugins, inventory plugins, callback plugins. For example, when we run a playbook against your servers, you don't have to specify anything because it uses what we call the SSH connection plugin, which is the default. So it's going to use SSH to connect to those machines. Now, however, SSH is not the transport for connecting to every kind of target out there. For example, imagine a network device may use something that is not SSH, like netconf. If you want to run a task against the AWS API, you don't SSH against AWS. You do a REST call against it. So that's why we have connection plugins, because you have variants there. For inventory, you can have like static files specifying your machines, but you can also dynamically discover your machines from, for example, a cloud on AWS, where you may not necessarily want to keep in Git or in a file your machines, but you want to have know dynamically what EC2 instances you have to run your automation against it. So that's a kind of a different inventory. Callback is for running certain events during the life cycle of a play. There are many different. You just can check, the documentation because it's very large. They're very easy to develop. Again, they use Python. You can ship them in a role. Now, so we have modules, we have roles, we have plugins. Let's say that you want to group them, or you want to get that kind of content for a particular domain. So that's what Ansible created, the concept of collections. A collection is a grouping of Ansible content for a particular domain. So you have a collection for iOS, you have a collection for Cisco, you have a collection for Dell servers, and then within that collection, you will get all sorts of things, roles and playbooks, plugins, modules, all sorts of things. Those collections, you either can install it from Ansible Galaxy. Ansible Galaxy, you can think of like a Docker hub of Ansible. It's a public website. You can just go and browse for available content, and then you can install it to your machine. So now we're going to talk about how we can leverage Ansible to automate Podman. So we can use it. There are like multiple use cases. We can use Ansible to build and publish container images because it's so easy to use. You can use it to take a Docker file, you can build it, then log into whatever registry and push it. We can use it for building cloud images with the prerequisites and containers configured and boot. Imagine that, okay, so I have now a role for configuring my containerized application. It would be good because I want to move it to the cloud. So it would be good if I could somehow create an AMI or a cloud image in which I would be able to configure that containerized application with systemd. So when I launch an instance with that image, it would just be running my application. It's the typical use case for using Packer, for example. This is the same. We can use Ansible for the configuration management of servers and the environment prior to deploy your containers. Imagine that you need to open ports in your firewall, and it's a network device, and how I can do that? Well, because with Ansible, we can integrate with everything. You can just, mesh that with your logic for deploying your containers, and everything is Ansible, and it's tightly integrated. We can create container networks and volumes. We can do backup restore of those volumes. That's another nifty use case. let's say we already have some containers running, and we want to make them, configure that with systemd so they're always, starting. If there's a restart or reboot or anything, we can also use it. As we said, because Podman allows you to do it, we can also, let's say we have Ansible already managing our Kubernetes cluster, and we want to migrate our Podman containers to it. Then we use it to just do that. And the other way around, we may want to migrate from Kubernetes back to Podman containers. So how we can do that? So there's a nifty collection called Containers Podman, which has been largely developed by a fellow Red Hatter called Sagi. He's a great guy, and he's done a phenomenal job developing this collection. It contains modules and plugins to manage Podman from Ansible, so you don't have to do it. You can just install that collection, and you are ready to go. This is just a set of the modules that you can find in that collection. So we have modules for managing containers. We have modules for building and publishing images, logging to registries, managing networks. Also for playing Kubernetes YAML file using Podman. So basically, you can, with that module, you can get a Kubernetes manifest and create a Podman container of it. You can manage Podman pods per se, and creating and deleting volumes. So now I'm going to show a demo. Hopefully, yeah. So I want to show in this demo how we can actually leverage Ansible to deploy a very kind of a hello world containerized application, and how easy it is by leveraging Ansible. So first off, I'm going to show you the inventory. So as you can see, I have an app service group, which is that IP, and there I'm specifying, okay, so I don't have to specify in the playbook, use EC2 user as the target user to log into it. And then I have the local host just in case. So we can actually use the Ansible command for, let's say, make sure that it has Python. So the target servers, in the case of configuring servers, you need to have like a Python in the target. So here we are using the ping module to make sure that we can run Ansible in the target machine. So what we're going to do, we're going to basically run this playbook. We're going to run against our target, which is app service. We just saw in inventory. And our task, we're going to import a role, which is OpenSouthCode, and it's going to run the deploy task from within that role. So what is that role? So that role, I have it alongside my playbook. So it's here. As you can see, here's my OpenSouthCode role. And within task, I have the deploy task, which we're going to go through. So what it's going to do, we want to deploy this containerized application as rootless. And for that, and we want to manage it with systemd. With systemd, you can have like non-root systemd services. But if you reboot the machine, they will be gone. To fix that, you need to do something that is called enable lingering, just so the systemd is aware of non-root user systemd services. So that's what we're doing in the first task. In the second task, we are doing a sysctl to allow the rootless container to bind port 80. By default in Linux, if you're not root, you will only be able to bind the port greater than 1024, I think it is. So that's what it does. Then after that, we're going to create a volume to hold some static files with containerized application. Here we call it app data. Then we're going to copy an indexed HTML file to the volume. And finally, we're going to, this is actually the payload, the meat of the playbook, which is creating a container. So the container is going to be called OpenSouthCode. It's going to use that image, which is Nginx unprivileged. Generate systemd, we're telling the module, hey, besides running the container, also create the systemd so we can start and stop it with systemd. Expose port 80 from the host, since we set the privileged bind port earlier in the task, we can do that. From port 80 down to 8080 within the container. And then use the update the volume and mount it under user share Nginx HTML. And then after it, since we're managing with systemd, we're telling here at the last task, hey, start within the user scope. So that's exactly what we're going to do. So as we said, we have the deploy playbook. So it's as simple as Ansible-playbook. We pass our inventory, which is the host file, and we run deploy.yaml. So it's going to run a play against my app servers, and it's going to perform the task from the task file. So it enables the lingering, allows a rootless container to bind port 80. It's going to create the application data volume, copy some HTML file to volume, create the Podman container, and then restart it with systemd. Let's see if that works. So, so this is the IP. So this is the machine. As you can see, so it's 133 is the same machine here. So if we SSH to it, we can do Podman PS, and there you go. So we have 34 seconds ago, we have our app running. However, we told the module to manage it with systemd, because we don't want to just have a raw container running. We want to have systemd managing the thing. So we can start it, we can stop it. If we restart the machine, it will just start, because we set the systemd service to be started as default. So if we do system-kettle status OpenSouthCode, there you go. So we have a service. It created the systemd service for the containerized application, and it gives me just like a regular systemd service. And I can stop it. Yeah, inactive. I can start it again, active again. Just a regular systemd. So this is actually the nice thing. So as you can see, it's so easy to automate the thing by using Ansible and the Podman and the containerized Podman collection. I want to see actually, and oh, by the way, if we go here to the IP, we can reload. Oh, so this is our app, a dummy app, just showing the index HTML that we put into the volume. It doesn't do anything fancy. And that's the main demo. If we have some time, I can try to run another one. What if we have a role for containerizing our OpenSouthCode application? Now let's say that I want to move from bare metal, I want to move to the cloud. It would be nice to have like an AMI image, which would configure it, install my app, and set it up with systemd so it just starts. So just so when I create an instance in AWS with that AMI, it would just run my application because it's already baked in. So I have this playbook. Build OpenSouthCode AMI, which is going to do that. So by leveraging Ansible, which since it integrates with everything, I can have a task which creates a temporary EC2 instance. Then I add it dynamically to the inventory, since it's not in my static inventory file. And then I can just reuse my OpenSouthCode role to deploy it against the temporary instance that I launched earlier in the playbook. Once the role finishes, I can leverage, all the things that we have with Ansible to create an AMI from that instance, since I'm running the role against it. That configures my application with systemd. And then once I have the AMI, I can just delete it and spit out into a file the AMI ID. So I'm not sure if we're going to have time, because saving an AMI takes some time, but let's try. So it's going to launch the temporary instance. So if I go to my AWS console and I refresh, as you can see here, OpenSouthCode temporary popped up. It's the instance that is just going through the play. So if we go back to the terminal, it's going to wait for passing the instance checks. So make sure that it can SSH to it, the instance is healthy, and then move on to the subsequent task. If you have questions, because this takes some time, maybe it's a good time to get some questions if you have any. Does anyone use Podman at all? Did you hear about it? Good. You use it? Good. So by the way, I'm using the Containers Podman collection, which is a community-driven initiative. However, if in your organization you use RHEL, which is the enterprise version of Red Hat Linux, they ship like a different set of roles for automating Podman, which you could also, have a look at. It's also, really good. It's just that I'm not going through here because it's an open source conference, and I just wanted to give like the other community, the alternate community version to automate Podman containers. So here, let's see if we have the status checks. Yeah, so it hasn't got the status checks yet. That's why, it's thinking a bit, initializing. Any how? Oh, go ahead.
It's a curiosity about the code, because if you put the full name of the models, is it a good practice or something?
It is. Yes. So, it will just work if you do. That's something that is called FQCN, fully qualified collection name, I think it stands for. Since Ansible created the collections concept, in order to not have a collision of names, it's like encouraging for you to do so. So like if you, for example, have you ever used Ansible Lent? It's a linter for Ansible content. So it will actually tell you, hey, you should actually use FQCN. It will just work, but it's like a best practice. Any other questions? Because this is going to take long. Cloud is slow.
I have a question about the files that you use to manage containers in Podman, for example. Like in Docker, you have Docker compose files. I don't know if that concept is not valid in
it is.
Podman.
So as a matter of fact, so with Podman, you can just use. There's like a Podman compose binary, which it supports Docker compose files.
Mm-hmm. So is there like a feature parity between
Yes.
Podman compose and Docker? Okay.
Yeah.
And then how about Docker files?
Yeah, you can just use them to build. Is actually what this is.
Same syntax, same everything, right?
Same.
Okay.
Yep.
Perfect. Thank you.
Oh, so now we got green. So it moved on. So it launched the temporary instance. It added dynamically to the inventory since we added something new during the play, and it's not in our static inventory file. And now what it does is that it's installing some prereqs, and then it's running the OpenSouthCode role that we have. So we're basically reusing what we have for bare metal for creating an AMI/cloud image for our containerized application. So it's going through the same task, creating the volume, copying the static files into the volume, creating the container, restarting it with systemd, and then once it's done, it's applied our role, it's creating an AMI from that temporary instance. So if I go to my AWS console, to AMI, and I refresh, I should have one which is in pending. I hate when it uses my localization for the language on the interface. But anyway, so that one is the AMI that is ongoing as part of the play. So this takes roughly, I think, like 5 minutes, because I think it's like a 10 gig, the T2 micro. Once it will be available, the AMI, the play will move on. It will delete the temporary instance since now we have the AMI, and then it will cat the AMI ID into a file so we can reuse it for subsequent. We can keep it for ourselves. Any other questions? Ansible in general, Podman in general. I'm more of an Ansible rather than a Podman guy, but I will try my best.
Does it take this time every time you update the containers and stuff, or it's just for the initialization of the pipelines?
I'm not sure I understand the question. What do you mean? Because what we're doing here, we're creating an AMI. What do you mean? For running your container, if I need to run Ansible?
For the process, for this process.
No, I mean, if we go here, this is like the first demo that we did. This is the machine where we run our play. Now we don't have to run Ansible anymore because my containerized application is here. So I have a systemd. I can reboot the machine. It will be there. I can start to stop it. I just use Ansible for the automation of creating the systemd unit, which itself uses Podman for running an application. But you don't need to use Ansible in an ongoing basis, just because it's already deployed. Yeah, sure. You had a question? Yeah.
When should you use Ansible roles versus include tasks?
Roles.
Roles versus include tasks. There's a command called include underscore tasks.
So typically when you have like in a playbook and you want to like reuse task within a role or within a playbook, and it's going to be very very short, you can use include task. However, when you want to encapsulate how to configure, deploy a particular service, that's something that you would use a role for. Because a role is something that you can just share in Ansible Galaxy or within a collection, and a colleague or anyone in the community can just use it. Since it's a reusable unit of automation and it's not tied to a particular playbook target host, that's what you use a role for. So include task is like in a different layer. It's within a playbook or even within a role. You can also use, you can also break it down, your role task into multiple tasks, and maybe you have like a common task file that you can include from other ones, if that makes sense. Good. Oh, it finished. So as you can see, so it created the AMI, and if I check here, OpenSouthCode AMI ID, so I have this AMI ID, which is CE820. So if I go to my console, it's this one. So we've run out of time, but trust me, because I tried this, the past few days. If I were to create an instance from this AMI, then I would have a VM that is just running my containerized application, just like the first one we did in the demo, and it would be, listening in port 80 with my application and everything. So it was just a use case that I wanted to showcase, that you can use Ansible also as well when you have a role for your containerized applications. Any other questions? Yeah, so actually, sorry, yeah, the last one. Sorry, I know that we are bad on time. That's my LinkedIn. I mean, if you want to connect, just search my name. I don't use Twitter anymore. I just use LinkedIn. And the slides for this thing, if you go to my GitHub, which is Ricardo Carrillo Cruz, you will find that repo. And by all means, I mean, if you want to talk to me, I will be around here maybe an hour or two. I'm happy to talk about all things Ansible, automation, Podman, whatever. And then, yeah, I mean, would be happy to connect with you. That's it. Hope you like the presentation.